glad that you're here this evening. And we're discussing what I think is one of the most critical and important issues in the creation-evolution controversy. Obviously, if the Earth's young, then there's no time for evolution, and the ballgame's over, we can go home. I think there's good evidence that that is the case. The evolutionist understands that it's absolutely essential that there be billions of years. And so if you're a naturalist, it's a philosophical compulsion to have billions of years. And it's not just a scientific issue with many, but it becomes a very emotional thing. And we want to try to evaluate it, however, strictly from the evidence. Many believe that the Earth is billions of years old, but it is not true that all scientists believe that the Earth is billions of years old. There are thousands, like, for example, Russell Humphreys, who has his PhD in physics from LSU and has 20 years experience as a geophysicist at Sandia National Laboratory, working in theoretical physics, along with a number of other creationists in such prominent institutions. But he will tell you, and some of his lectures are on the internet, that most of the age indicators in the world that we live in favor a young Earth. He says 90% of them. We hear most about the 10%. But he says 90% of those indicators indicate a young Earth. And in the last lecture that I heard, he had 12 of those indications that he talked about in about an hour-and-a-half lecture. We won't take time to go through those this evening, but I would recommend his lecture. We will look at some of the indications of a young Earth as acknowledged by the old Earth evolutionist before we conclude this evening. But we need to understand the philosophical necessity that the evolutionist has for the old Earth and the role that it plays in their thinking. It is absolutely critical, essential. George Wall, who's a Nobel laureate, is expressing that philosophical necessity and the role, the essential significance of this issue when he says one has only to contemplate the magnitude of this task. He's talking about the origin of life and the complexity, the interdependent complexity that we see in life makes it a real challenge to imagine this happening naturally. And he says one only has to contemplate the magnitude of this task to conceive that the spontaneous generation of a living organism is impossible. Yet, here we are as a result, I believe, of spontaneous generation. It's impossible, but he believes it. Well, how do you do that? However improbable we regard this event, or any of the steps which it involves, given enough time, it will almost certainly happen at least once. Time is, in fact, the hero of the plot. You see, this is essential to solve the impossible problem. Given so much time, the possible becomes impossible becomes possible. The possible probable, the probable virtually certain. One has only to wait, and time itself performs the miracles. Now, I don't believe time has that miracle property. In fact, what we learned last night about the second law of thermodynamics tells us that with time, things go downhill. And most of us, or many of us, certainly know that time is not a friend. It goes in the opposite direction. Time is a disorganizing agent, degenerative agent, not that which miraculously turns the impossible into the possible. But that's the fairy tale that's told. We've all heard of the fairy tale of the princess that kisses the frog and then magically turns into the prince. That's a fairy tale unless you add the magic kiss of time, and then it's science. Now, if you think that's an exaggeration, you just have to stop and think about it. That's exactly what's taught in our universities. Given enough time, the frog turns into the prince. It just takes time. Does it have that miraculous property? I don't think so. I think it has the opposite effect. But one of the ways to approach this subject, scientific ways to approach the subject, is to ask why. You believe this? Why do you believe this? Many believe the earth is old, and they're told over and over again that the earth is billions of years old. And the why question is a good place to begin. And when we ask that question, usually the answer that we get involves radioactivity, or the first answer that we get. And of course, everybody understands how this indicates great time, right? And understands radioactivity. And we won't try to educate everybody and make you experts in this field, but I think we can understand it in a general way. It typically involves large molecules that begin to decay. They emit alpha or beta particles from the nucleus of the atom, and through this decay process, lose particles and become different elements. It decays. It's not stable, down to the point where they decay no longer and then become stable. But it goes through a series of a number of elements before it reaches that stable form typically. For example, with uranium-238, you begin with 238 particles, and those begin to be emitted. They're not stable, they're radioactive, and they decay through a series of elements down to, through radium and so forth, down to lead with 206. So from 238 to 236, the decay process winds up stable with lead. And this decay process, we're told, tells time something like an hourglass. And if we were looking at an hourglass, and you look at this illustration, how much time would have transpired? We would say, well, if this is an hour from the top to the bottom, then you're looking at, maybe 20 minutes, maybe 15 minutes. And if you could count the grains of sand and knew precisely the rate, then you could come up with a very precise conclusion about the age. And counting the atoms is not the challenge. We can do that very accurately. The rate of decay is something that many have great confidence in. I think there's reason for that confidence to be eroded, and we'll talk more about that later. But through the equation that we see at the bottom, we're supposed to be able to reach a conclusion about time with the decay of uranium-238. There's a half-life of about 4.5 billion years. And that's what we're told has happened in the age of the Earth. What kind of a problem or kind of problems can you imagine that would go wrong or could be a difficulty with this kind of a time-telling mechanism? Suppose, just before you were asked the question, how much time has transpired, someone had lowered the base and let out a lot of extra sand at the bottom so that most of it had already gone to the bottom, but now it looks like just a small amount has gone to the bottom. That would skew your conclusion, wouldn't it? Or, just before you were asked, somebody raised the top and piled in a lot of extra. And now that's going to mess up the conclusion. Or, suppose it looked basically like this, laying on its side. This was the beginning condition, virtually. And then they set it up, and now how much time has transpired? And it's been 20 seconds, and you say 20 minutes. That's going to fall. You've got to know the beginning conditions. You've got to know how much was at the bottom to start with, assuming that it was zero is not a valid assumption. We know lead occurs naturally as well as radiogenically. It's a matter of guessing at how much was there to start with. And through a series of assumptions, may or may not be appropriate, we see conclusions reached about the age. You measure a rock not by That is, you measure the sample activity of the rock. You don't look at the rock and see a watch face. You don't technically date rocks. You measure sample activity. And we see how much uranium there is proportionate to the lead, and through these assumptions reach the conclusion about the age. Notice the statement by Henry Fall, who's one of the leading authorities in this field, certainly believes in the billions of years. He says two important assumptions are implicit in this equation. That was what was at the bottom of the previous picture. First, that we're dealing with a closed system. That is, nothing leaked in, nothing leaked out. Does that happen with rocks? We know of things becoming petrified. How does that happen? Well, water percolates through the rocks and leaches out certain materials, adds other materials, so that you have a seashell that becomes pyrite, metal. And it looks just like a seashell, but it's no longer that. It's leaked in, leaked out. This happens certainly over billions of years, if that much time were involved. That's the first assumption. Second, that no atoms of the daughter, that's what's produced at the bottom, the lead in this case, were present in the system when it formed. We've got to know what the beginning condition, we don't. Those are important assumptions. He says these assumptions furnish the most serious limitations on the accumulation clock, and then adds rigorously closed systems probably do not exist in nature. Well, no, they are exposed to leaching and addition. But surprisingly, many minerals and rocks, he says, satisfy the requirement well enough to be useful for nuclear age determination. The problem is one of judicious geologic selection. And so we're not talking about an objective process here. We date the rock and boom, there's the answer. Maybe it is, maybe it isn't. If it doesn't come out right, you chuck it. If you pardon my bias, I think I have had experience and have seen that happen. We'll give you an illustration of that. Notice from the evolutionists themselves, regarding the 1470 skull, Richard Leakey made this discovery, and his friend Roger Leland, who's editor of Research News and Science magazine, describes the process of dating this critical skull. Critical if it's the right age, and that's what makes it critical. He says the calculated age was quickly refined to be 2.61 plus or minus 0.26 million years, which to anthropologists unfamiliar with the procedures of radiometric dating, if you're unfamiliar with that procedure and don't really understand it that well, you're not by yourself. Even anthropologists don't. They just take it to the lab and say, here. Not quite. They say, here's the age I want, here's what we expect it to be, and if you don't tell them the answer, they won't do the dating. Now, when I was taking tests in school, I didn't get the answer before I took the test. But if you look at the forms, in fact, you can look it up online, here's the form you have to fill out if you want to submit a sample. You got to tell them what you expect it to be. But it sounds very precise. It has a ring of comforting precision about it, Leland says. But he continues. There were 41 separate age determinations. They dated this skull 41 times, which varied between 223 million and less than 1 million. 0.9. Now, 223 to less than 1 is a huge range. Well, you just take the rock and get the answer. Well, but here's 41 different answers ranging all over the place. This is not my description of it. This is Roger Leland's description of his friend's process of dating the skull. And after the first determination, they never again obtained 2.61 from their experiments. But that's what's published, and that's all you get. It's 2.61, plus or minus 0.26 million, which I think is rather deceitful. When you learn the rest of the information, it's a matter of judiciously selecting which one you think it should be. It's a game to confirm what you've already concluded. And that may sound cynical, and many would disagree, but I think with the doctrine, well, that's basically what you say here from the evolutionist on words. We can see some other challenging issues when we go to what I call the proof of the pudding type arguments, where you get known ages, rocks that you know when they started, when they were born, and you date them and you see how it comes out. Now this is the caldera at Mount St. Helens, and it of course exploded first in 1980, but the particular mound in the beginning, in the middle here, in the middle of the caldera, a special type of rock that is especially appropriate for radiometric dating, occurred in 1986. In 1997, we took 5 samples, diabase rock, from the center. Now, it occurred in 86. We took the samples in 97. Can we figure out how old that rock is? 11 years old, right? We sent it to the UCLA dating lab. The result came back in millions. Now, somehow they slipped past the gatekeeper. I have a suspicion, maybe I didn't submit the samples, but some friends of mine did, and maybe they, anyway, they got past telling them how old it was supposed to be. The dates came back in millions, from about 500,000 to almost 3 million for rock that was actually 11 years old. Obviously a problem here. Well, then this stuff that came out of the center, then obviously you're not dating when it formed. Well, of course, the assumption is that when it's lava, all of the gas, the argon, this is potassium-argon dating system, all of the argon will escape, and it resets the clock to 0, and it starts to decay again and accumulate the argon. Once it hardens, well, obviously it didn't all escape. But that's the fundamental assumption of the system. It's supposed to tell you when this rock was formed, based on the 0 reading when the argon escaped. Well, it doesn't. It didn't. It didn't work. That will give you an illustration of some of the problems and why many don't have the confidence that is implied in the reporting in some of the TV programs that we hear. Radiocarbon is probably the system that we hear most about, but is not as significant with reference to evolution because it doesn't cover as long a period. You have all of this decaying within 50 to 60,000 years, not the millions of years of the potassium-argon or the uranium-238 systems. But notice the statement by Robert Lee. He said it should, and of course, if you find something 50,000, 40,000, which would be within the range of radiocarbon, then I think that would be a challenge to what the Bible, for example, tells us. Lee says it would be no surprise then that fully half of the dates are rejected. The wonder surely is that the remaining half come out to be accepted. Well, we had 4 rejected, 1 retained. He says half are rejected. I think that's a very conservative estimate. A friend of mine at Ball State was running the carbon-14 lab there. It was dating a peat log. When I visited, he was very gentlemanly. We had, I think, a reasonable discussion, though we disagreed. He was sure the peat bog was 20,000 years old. He had dated 19 times, and all of them came out 4,000 to 5,000 years, which in his mind proved that it was contaminated. And so he's continuing on his 20th effort. He's going to get a good one yet. This is the way it works. He says at least half are rejected. There are gross discrepancies. The chronology is uneven and relative. The accepted dates are actually selected dates. Now that's not objective science. It's represented that way. It is not. And those who are familiar with the field know that, and if they represent it otherwise, I think they're misrepresented. We did some very important experiments, I say we, friends of mine, in the RATE project. Let me introduce you to the four scientists who were involved here. John Baumgartner, who has his PhD in geophysics and space physics from UCLA. This is no lightweight. He's a staff scientist at Los Alamos National Laboratory. Now, some people think all creationists are ignorant and are not qualified. Well, that's just foolish propaganda. Russell Humphreys, that we mentioned earlier, PhD in physics from Louisiana State University, nuclear physicist at Sandia National Laboratory. Stephen Austin has his PhD in geology from Penn State, chairman of the geology department at ICR Graduate School, and then Andrew Snelling, who has his PhD in geology from the University of Sydney. This was the team that was in charge of doing the experiments. And the first projects involved dating dinosaur bones and diamonds with carbon-14. Now, many scientists would say this is crazy because all of the carbon-14 is going to be gone within 40 to 60,000 years. And these are hundreds of millions of years old, billions of time. And so all the carbon-14 would be gone. It's all going to be gone 60,000, and this is supposed to be 65 million or 100 million. Well, but let's just play the game and see how it comes out. If we date it and there is carbon-14 there, that means they're not 40,000 years old, let alone 100 million. They should have no carbon-14 in them. The truth is, with over 100 samples of dinosaur bones and over 100 samples of diamonds, all of them, every one of them, 100% had significant amounts of carbon-14, hundreds of times above the background. Something is bad wrong with the system. And maybe the most significant part of the RATE project involved dating coal. Now, one of the just a priori assumptions of the evolutionists and creationists, they're ignorant and they don't know how to take samples. These men do. But in order to sidestep the idea that maybe it was contaminated, which is what we want to say, regardless of the evidence, they used samples that were collected from the U.S. Department of Energy's National Coal Sample Bank that's maintained at Penn State University. It's collected by them, maintained by them in sealed conditions, under refrigerated conditions, actually, at Penn State University. Contamination, well, we didn't take the samples. They took the samples, and these were samples from all across the United States, from all, quote, ages of rocks, from all up and down the geologic column, from Eocene, Cretaceous, and Pennsylvania, which are supposed to range from 300 million to 50 million years old. And let's use carbon-14 to see if there is a significant amount there. It should all be gone. But the coal from these different, supposedly, ages of rocks all came out basically the same thing, with radiocarbon, and there was plenty of radiocarbon in them. All the radiocarbon will be gone within tens of thousands of years. They're supposed to be tens of millions of years old, and can you see that there's a significant problem here? I think that's a very significant test, and that's of course been published, and I think it's a significant challenge. I think we can say that this is now a creationist friend, which indicates that these things that are supposed to be hundreds of millions of years old are tens of thousands of years old. We see thousands, not billions, is the best answer. What we're looking at is assumptions that are not valid, that are necessarily inherent in this process. We have to assume that the system was closed, and we know that doesn't exist, but we're just guessing at what is and what isn't, depending on whether it comes out or not. We have to guess at the beginning conditions. And that's, if you have to guess at any step along the way, you might as well guess at the answer to start with. And then you have to assume that the rate is constant, which is just asserted dogmatically. I think there's very good evidence that it was not constant. And if you have questions about that, we may address that later. We won't have time in this session. We see that known ages contradict the dating results, such as with Mount St. Helens. We see that things that are supposed to be old are not old with carbon-14. Well, but you're using the wrong system. Well, but the system should take the carbon-14 if it's there, and of course it is there, it should be gone. Well, you use the older systems. Well, sometimes it's kind of like trying to date a 100-yard dash with a sundial. You're using processes that are inherently going to give you long ages because of the process you choose to use. And that's the way you get the old ages. Notice the statement by W.D. Stanfield, who is a vicious anti-creationist. He's a professor of biological science at in California Polytechnic State University. He says it's obvious, after looking at some of these obvious contradictions and challenges, it's obvious that radiometric technique may not be the absolute dating methods they're claiming to do. Well, yes, I would say, duh. With the kind of challenges that we presented, that should be obvious. He says age estimates on a given geological stratum by different radiometric methods are often quite different, sometimes by hundreds of millions of years. You date the same rock by different methods, you ought to get the same answer if they're accurate, right? But no, you get radically different answers if you use radiocarbon, if you use potassium argon. Therefore, he says, there is no absolutely reliable long-term radiological clock. Now, that's not the creationist saying that. That's the anti-creationist who has investigated and has seen the challenges, and I think that's a valid conclusion. If that's the case, now, why? What are the good reasons for knowing that the Earth's old? Radiometric dating is a game being played that often comes out thousands rather than billions, depending on which method you choose. The next answer that we get to our why question usually involves the geologic phenomenon. Things on the Earth, the geologic factors, appear to be old. You look at all of the layers, you look at all of the fossils, the coal and the oil. This takes millions of years, right? And so that's why we think the Earth is old. Well, you look at the geologic layers, and we've been told how long it takes to form these since 1931. This age and the ages that were first published in 31 have been repeated and repeated. You can find the same ones still in textbooks today. And they look something like this. In the Paleozoic, which is the majority of it, we're looking at about almost 3,000 years for a foot of limestone, sandstone to form. The Cenozoic, it takes 1 foot, 1,400 years. Now this is actually relatively slow. This was back in 1931. Many of them have said it's slower than that. Here, for example, Officer and Drake in the Great Dinosaur Controversy say a rate of 1 centimeter per 1,000 years is typical. Now, Schuster said 1 foot in 3,000 years. This would be 1 foot in 30,000 years. Now, both of them sounded very precise. 1 foot in 30,000, 1 foot in 3,000. That's pretty different, isn't it? But, yeah, they're all very certain. Or 2.5 inches in 1,000 years, depending on which authority you quote. Dunbar and Rogers wrote the book Principles of Stratigraphy, which I was taught from actually in 2 state universities. Stratigraphy is the study of the strata, the layers in the rock. And many people assume, all right, here experts in the layers, they know they're old. Well, he says we had some challenges here when we were told it's billions of years old by the radiometric dating people. To some thoughtful stratigraphers, this amazing discovery, billions of years, presented a dilemma. It wasn't what was expected. It was a dilemma. For if the non-stratified rocks have been accumulating throughout this vast span of time, the average rate of deposition must have been extremely slow. Yet there is very good evidence that individual beds accumulated rapidly. Very good evidence that individual beds accumulated rapidly. What kind of evidence is he talking about? Well, you look, for example, at the shrimp. Looks like a shrimp, but it's not. This is a rock. Now, you ladies know that you can put the shrimp in the refrigerator and it'll just last for years and years and years. Or does it? What happens when it dies and lays out on the beach? How long is that going to last? This one lasted long enough to become a rock. Well, how long did it take that rock to form? Millions of years, or thousands of years, or tens of years. That's not going to happen, is it? Very good evidence that individual beds accumulated rapidly. This is what he's talking about. I have dozens of shrimp, beautifully preserved in rock. Some limestone, some sandstone, some shale, that are preserved like within, it has to be within days. Looks like within hours of the death. That rock didn't take long for us. And if you're just honest enough to think, it won't hurt, let's just try it. You know that rock didn't take a long time. I have 3 samples of fish like this called aspirations. They're not that unusual in my collection. These are some that are friends of mine. Here's a fish eating itself. Now, I enjoy eating with my friends, my brethren, from time to time, and some of them are kind of slow, and it's a little aggravating sometimes. You have to sit and wait. 100,000 years would be ridiculous. How long did it take these rocks to form? Can you imagine it taking 10 years? Would the fish look like that? Or did these get caught in the concrete? Forming rapidly. I think that's, anybody who's willing to think can see, obviously, it didn't take that long. Up above Knoxville, Tennessee, Cumberland Mountains, we see in a coal seam, and this has been excavated down to the seam that I'm sitting on there in this picture, which is coal, so that they can, of course, carry that out. But notice what's exposed in the process. This is actually not a tree. It looks like a tree. It's a fern, a fossil fern, a philodendron, that's at least 12 feet, that extends up into one coal seam and down into another one with hundreds of layers in between. Now, if each of these layers took thousands of years, what's going to happen to the top of that tree? The fern, that is. And this is not unusual. Here's another example from Nova Scotia. And here at this site, it's not just this one example. We back up to get a wider view and we can see 4 what are called polystrate fossils that go through many strata. That says this didn't happen slowly. How long did this take? At the sedimentation rate that's postulated by Schuster, 32,000 years would be required, and by the rate offered by Officer and Drake, it's 360,000 years to cover the tree. And the tree is just as well preserved at the top as it is at the bottom. How much time? I think a much better explanation for this is that this was one catastrophic event. What would it take to cover trees like this, or large ferns the size of trees? It would take something like a flood. And that would catastrophically preserve. And as we look at the coal at the bottom, what would that say about the formation of the coal? It would have to be rapid, wouldn't it? Because it extends into one coal seam all the way up through another coal seam. Again, that doesn't take long. We can do that in the lab in about 6 hours. Likewise with oil, which we're told takes millions and millions of years. Notice here from Discover magazine, which is certainly no friend of the creationists. Turkey guts, junk car parts, even raw sewage go into one end of the plant, black gold comes out the other end. 2 hours later. It doesn't take that long. We see ferns. Some of you ladies have some experience with the ferns and know that, well, how long does it take a fern to wilt? This is in coal that is preserved, had to be rapidly. Here's one that's held over, bent, like the live one at the bottom, but the top one is not live, that's a rock. That was formed into a rock before the fern could wilt, before the fern could spring back. Notice the statement here in Science Daily last year. The preservation happened so quickly that some of the cells have even been preserved during different stages of cell division. They found the cell nuclei, the cell membranes, even individual chromosomes preserved so rapidly, and then slipping into a different point. They look exactly the same now as they did back in the Jurassic period. Well, these are the kinds of problems that Dunbar and Rogers are talking about when they say there's a lot of evidence in the rocks that say it happened rapidly. We see the ichthyosaur. This one is 28 feet long, preserved in the limestone. Some of the adipose tissue here across the top of the head is beautifully preserved, all formed at the rate of 3,000 years a foot. You think? Looking at the interior, we see this is a Mrs. plesiosaur with the embryo preserved inside. There was a catastrophic circumstance that caused premature birth with dozens of samples in this example in Bavaria, in the Solenhofen limestone. And here we see the baby ichthyosaur prematurely being expelled. Now, I can sympathize with the ladies who think this process takes hundreds of thousands of years when you're in the middle of it. But it really doesn't take that long, does it? Here's baby ichthyosaur in the process of coming out. An article just last year, PLOS, again shows the perfect preservation of the plesiosaur, and said they captured a moment of live birth with the baby emerging from the pelvis of the mother. In the rock, in the limestone. Now that did not happen slowly. It ain't so. And all you got to do is just look and think. You might recognize the octopus here from paleontology, preserved octopus as a fossil. Sometimes they'll say, well, the reason you don't find all of the missing parts is you don't have the hard part. Well, the octopus has no hard parts. It's complete with ink sac and suckers, as unlikely as finding a fossil sneeze. These things are 95 million years old. Yet one of these fossils is almost indistinguishable from living species for 95 million years. That's a point we made last night. And then we'll have our break after we show you one more example. You recognize this as the jellyfish. That's about as ephemeral as, in fact, we were talking to a junior high class and asked asking what this was made of. And one little girl waved her hand. She says, "It's made out of snot." But it's substantial enough to be preserved as a fossil, along with the ripple marks, which don't last long either. But here are the fossilized jellyfish with the mouth parts beautifully preserved up in Pennsylvania. Science indicates that fossils did not happen slowly. If you'll just stop and think about it, there is very good evidence that the individual beds accumulated rapidly. And it's not Sunday school lessons. It's the actual empirical evidence in the rocks that is absolutely undeniable. All right, let's turn the lights back on and see if somebody has some questions. Lights down. Things like jellyfish, preserved as fossils, say this is good evidence that it did not happen slowly. It happened rapidly. But there's even better evidence than that. Soft tissue is regularly preserved in the fossil record. And here, from Phys.org, is the quotation about the Burgess shale, which is at the lowest part of the fossil record, we're told, even earlier than the earliest Cambrian in some instances, so that's debatable. But soft tissue is preserved in exquisite detail, and the question of how this came to happen has troubled scientists since the discovery of the fossils in 1909. That is troubling. These examples, this is Phys.org's description. It does trouble scientists. But what about soft tissue preserved in the rocks that's still soft? Stinks. And we found more and more of that, especially of late. This was back in 1993. And we're looking at a cross-section of a T-Rex bone. And these are T-Rex blood cells, which shouldn't be preserved in a 100-million-year-old bone. Blood cells. Mary Schweitzer was the one who first published this, and has since have been challenged and then defended and got even better information. But she's showing here the squishy, soft material that was within the T-Rex bone. And this was reported in Discover magazine several years ago. She said, I had one reviewer tell me he didn't care what the data said. He knew that what I was finding wasn't possible. Don't care. We had people reason with us that way, maybe about the Bible sometime. Don't care what it says. The mind is made up. It's impossible. I wrote back and said, well, what data would convince you? And he said, none. I think he was telling the truth. These are 65 million year old, and in fact this one was 100 million years old. You can't have soft tissue. Well, I understand his dilemma, because he's not going to turn loose of his millions of years. I've interviewed her on more than one occasion, and in the letter in our exchange, she did acknowledge our current theories do not account for soft tissue and cellular preservation. You can't explain this in terms of what we know about soft tissue at this point. She has viciously been challenged and defended herself. She's now at the University of South Carolina and has recently published, year 2012, a complete defense, and this has not been responded to. I don't think anyone's tried that answer. Analysis of dinosaur bone not only preserves the soft tissue, but protein sequencing, preservation. More evidence, she says, for the preservation of ancient dinosaur proteins. Now, I asked her face to face, I have heard that you have found DNA in the dinosaur bones. Heard about that in Jurassic Park. The idea of reproducing a dinosaur from the DNA is pure fantasy. But finding the DNA would have to be fantasy for one that believes it's 100 million years old. DNA is very fragile. Our own DNA is damaged every day with the cosmic radiation. We are constantly repairing it. And so if we die, we quit repairing it. It's being deteriorated not only by water, by air, but even it completely sealed by the cosmic radiation. And the experiments demonstrate could not be longer than 10,000 years. Some would say, well, maybe 100,000, but they're stretching it. If you find DNA in the dinosaur bones, that's supposed to be 100 million. Well, it's just not possible. You can't do that, but she did. Well, she wouldn't say that she did. I asked her, she said, well, we found the proteins. And that's almost the same thing. But some of the ones that worked with her told me, yes, we have found the DNA. But in this article, she went a little further and she says, and possibly DNA. She's not ready to take all the flack that comes with saying she did. But those who worked with her have told her, yes, she did. And then she says in this article, possibly. And so when we see this in the bones, we see this can't be old. The sequence protein certainly. Apparently the DNA. This says the dinosaur bones are not old. Now, I don't think there's an answer to that. Now, let's think about that. Looking at the layers, if the layers are not old, or the dinosaur, or the fossils in the layers are not old, then the layers themselves are not old. Wouldn't that follow? If the fossils are not old, then the layers they're preserved in would not be old. And if that's the case, where's the time? Well, there's an answer that they give to this. They have basically, at least, I don't know that we could say the majority, but close, and possibly the majority, will acknowledge, yes, the individual layers we know had to form rapidly. We've virtually won that battle. But today's answer is the time is in between layers. Yes, they are rapid, we can see that, but the time is in between. I say you mean where there is no evidence. But that's overstating the case because there is evidence there. But instead of my representing that, let's notice a statement here by Derek Aker, who was at the time president of the British Geological Association. And notice the title of his book, The New Catastrophism. Now, he doesn't believe in Noah's flood. But what we see in the layers says this is a catastrophic deposition. And he has to acknowledge that. We can't escape the conclusion that sedimentation was at times very rapid. But, he says, there were long breaks. And that's where he puts the time. So he still believes in the long ages. But there are breaks in between the layers. Though it looks uniform and continuous. What do you see in the breaks? You see nothing in the breaks, and it doesn't look like there's a break, but it has to be there. And this is the way they think. It looks uniform and continuous. Now, when you understand what's going on with the deposition of these layers, you understand that it looks uniform and continuous, just like he said. If you have a layer at the bottom of the ocean that is knife-edged, it's not going to stay that way long. You've got plants that send their roots down through it. You've got worms that burrow through it. You've got clams that leave little trenches. It just plows up the surface. What they call bioturbidation destroys any smooth surfaces. It looks like that didn't happen there. He continues saying, the geologic record is constantly lying to us. Now, it looks uniform and continuous, but no. It pretends to tell us the whole truth when it's only telling us a very small part of it. Nowhere in the world is the record or even part of it complete. In between, you've got a lot of stuff that's not there. How do you know if it's not there, how do you know? Well, it has to be, because time is a necessary proponent of his philosophy. He said, it may seem paradoxical, yes, but to me, the gaps probably cover most of Earth history. Now, I was taught we go by the evidence, not what's not there, the gaps in the evidence. But now the gaps where it's not there is where it's at. It was during the breaks that most of the events probably occurred. How do you know? Well, it's not there. It's the gaps that really matter. No, I don't think so. I think it's the evidence. What is there is what matters. And when you go by what is there, it says rapid and uniform and continuous. You look at the gaps, and this is down near the bottom of Grand Canyon. Here's the Coconino sandstone laying conformably on the Hermit Shale. The problem is that as you look at the critters in this and the dates they assign to them, you're missing about 110 million years. This is their explanation. Well, how do you do that? Well, if you've got deposition here, you've got to have erosion somewhere else in order to be able to deposit it here. And so for 110 million years, you had erosion that left this straight level knife edge. Is that what erosion looks like? You seen erosion? Does it leave the knife edge? I don't think so. But that's what he's saying. We have straight and smooth contact lines, no bioturbidation. That says it is what it looks like. It's uniform and continuous. Time produces erosion, and that is not there. It's straight and smooth contact lines for the length of the canyon, which exposes all of this sedimentation. But let's look at the contact lines. I say where there is no evidence, not so. There is evidence there. You see little bird tracks. Now, that will erode in tens of years, just a few, but it's just like it was done yesterday. I think basically wet concrete, that's the deposition from seawater, another lecture subject, but that's what happens. And exactly what accounted for the global layers as a direct prediction of the flood. But in this basically wet concrete, they were walking, and in order to keep that from being eroded after it formed rapidly, it had to be covered rapidly. Typically, you see the ripple marks, you see the raindrop impressions, you see the animal tracks. In order to preserve that, this has to go quickly. One of the more dramatic examples of that here with the ripple marks are the dinosaur tracks down in Glen Rose that we'll be talking about tomorrow evening, Glen Rose, Texas. Now, in order to preserve these very ephemeral markings, next rain will take away the ripple marks and a good bit of the dinosaur tracks. This has to turn into rock quickly, as it did with the jellyfish, in order to preserve this. But then once it's preserved, it'll still erode quickly if it's exposed, especially in limestone. And so the next layer has to come quickly in order to preserve what is formed rapidly in the rock below it. And so when you see that you've got ripple marks all the way up and down the canyon, in fact, ripple marks are the most common sedimentary feature in the sedimentary record. It's been said that any contact line you follow far enough, you will see ripple marks. Virtually all layers have. And in order to preserve them, the host rock has to be formed rapidly, and then the rock on top of it has to be formed rapidly. It has ripple marks on top of it to preserve, has to be formed, and so on up and down the canyon. Virtually all had to be rapid when you understand how these ephemeral markings are preserved at the contact lines. But it gets worse for the evolutionists. Trying to explain time, looking at this picture. This is the Red Wall, Mississippi, the more dramatic layer that people see from a distance as they look at Grand Canyon. Below it is the Buoff Cambrian. That's the bottom layer, the lowest sedimentary layer. The Red Wall is about well over a third of the way, almost halfway up. And so there's a ton missing in between. You've got the Cambrian, Ordovician, Devonian, Silurian. All of this is gone. Some of the Devonian in a few places is there, but most of it here is completely gone. Most of it is gone. All of it. Well, maybe there's erosion during that time. So you skip about 150 million years to go from the Nuoff to the Redwood. Well, okay, they can explain maybe erosion will account for that. But notice you got the Nuoff that goes to the red wall, but then it goes back to the Nuoff. Wait a minute. You go forward 150 million years, and then you go back 150 million years to get some more Nuoff, and then more Redwall, and then more Nuoff, and then more Redwall, and back and forth 8 times. How do you skip 150 million years 8 times and go back and forth? It's not possible. Now, what we were taught in stratigraphy is that if you have interbedded layers, you have contemporaneous layers. They were laid down at the same time. Does that make sense? That's just common sense. If we understand. That's what you see with these layers that are supposed to be 150 million years apart, according to the geologic column. They are interbedded. They cannot be millions of years apart. It proves they are contemporaneous. This looks uniform and continuous, and it is. I presented this across the country, and I've yet to hear somebody try to answer that. If they are interbedded, they are contemporaneous, they cannot be millions of years apart. And that just destroys the idea that there are millions of years in the gaps where there's, quote, no evidence. Okay, if this all happened rapidly, how in the world do you lay down all of these layers rapidly like this? Well, I think we have a demonstration of that at Mount St. Helens. This is a small version of the kind of catastrophe that was designed to destroy the world that then was, which was a supernatural judgment. That's the model that we're testing. But here at Mount St. Helens, 1980, we had a huge explosion that blasted out a pyroclastic cloud across the countryside at about 150 miles an hour. Tremendous amounts of debris spread across the countryside, dumping the trees here into Spirit Lake. And then after all of this sediment, up to 600 feet of layers of sediment laid down across the countryside, Spirit Lake's dam broke and then eroded right down through the middle of the newly laid sediment, leaving this canyon with a little trickle down at the bottom that was completely caused by that little trickle. You think? Or was there an immense amount of water that caused that huge canyon and left a little trickle at the bottom? You look at the sides and you see these layers that were laid down at 150 miles an hour, most of it in one afternoon. Layers like you see at Grand Canyon. Would this look like what you see on the cliff today that's supposed to be hundreds of millions of years old? That's rock. You hit it with a hammer, it rings like a bell. This was laid down one afternoon at 150 miles an hour. And then eroded through with a tremendous amount of water, catastrophically, leaving the canyon. That looks a lot like Grand Canyon, about a 40th scale. This looks like Grand Canyon. I think that's what this, I'm sorry, this is Grand Canyon. This is the canyon at Mount St. Helens, with a little trickle down the bottom, which is what's left. Reminds me of the cartoon friend of mine drew. This million-year-old canyon was formed by Mount St. Helens in 1980. It didn't take a long time, nor did Grand Canyon. I think we can demonstrate that for a dozen other reasons as well. We go to caves, and especially in the commercial caves, they'll say this takes hundreds of thousands of years. I was taught at Indiana University it took 100,000 years to form 1 cubic inch. That was in the textbook. And so if that's the case, then these formations, the speleotherms, the stalactites, stalagmites, would take a long time. Of course, that's what's told. Though we can see these things growing very rapidly. We'll talk more about that in a second. But let's just give an example here from Vincennes, Indiana. George Rogers Clark Memorial on the banks of the Wabash River, which is on the clay bank right on the side of the river. And the limestone that you see here came from about 4 miles from the cave that we just looked at in the previous slide. This is the Bedford limestone from the Bedford quarry. And the water percolates down through the cracks in these rocks just like it does in the caves. I was told by one of the representatives from the National Geological Society, I've been a member of for 40 years, that he had found stalactites in the bottom or in the basement of this memorial, but they would not allow him to take pictures of it. Well, I decided I was going to get pictures of whatever was there, and we worked with the state representatives who threatened to cut off their funding because they would not allow this to be documented. Anyway, by the time I got there, I think I could have taken one of the columns home. I was a guest who was ushered in, and sure enough, in the basement you see the same kind of speleotherms that you see in the caves in this building, which at the time was 40 years old. 5 columns, 11 feet tall. 40 years old. You go to Carlsbad Caverns, you see huge formations. How long does this take? Well, we know the factors that are involved, and the factors vary, and so the formation rate varies, but there are some indications clearly that it does not take a long time. There are lots of bats in Carlsbad Cavern, and they fly around, and some of them are kind of slow. This one was real slow, enough to get caught by a stalactite. A trapped bat, which if he died and laid there while the thing grew, it would have to grow pretty quick before it would rot, wouldn't it? But it grew quick enough to trap the bat. How long does that take? Hundreds of thousands. 1 cubic inch, 100,000 years is what the textbook says. We have a technical term for that down in Arkansas, where I'm from. It's called hogwash. This is a boot that I recovered from Alabama, Texas, out in West Texas. And it's not petrified, semi-petrified, but basically not. But what's on the inside is the bones and even part of the flesh of this unfortunate cowboy is rock, petrified. You see how it's kind of broken away. And then looking close at the wounded part, you can see even part of the pus petrified in a boot that we've identified from the J. Letty Boot Company in Fort Worth that was made in the early 50s. We took it to the hospital where they had a CAT scan that could see what's on the inside. They wanted to know what kind of name to put. They normally have names when they do CAT scans of feet. And it came back, unfortunate cowboy. We prefer to call it the limestone cowboy. But here's a petrified cowboy leg from 1950. How long does it take to petrify things? We asked that earlier. Here's a pretty good demonstration. When we look at the geologic phenomena, when we look at the fossils, detailed fossils, polished, straight fossils going through many strata, like the shrimp and the jellyfish and the ferns and the trees, the soft tissue, this can't be slow. This has to be rapid. When we look at the continuous sequential layers indicated by the ripple marks, which have to be formed quickly and then preserved quickly, Mount St. Helens demonstrates how that happens. When we look at coal and oil, petrification, all of these processes are rapid. All of them. Now, why do you think here it's up? The radiometric dating system again to confirm what we've already concluded, and certainly not an objective process. And the geologic phenomenon are all rapid. Why? Well, we just hear the propaganda. We need to ask why. Stanfield, that we introduced earlier, is the anti-creationist in California, who in his book acknowledges there are some really good indications of a young Earth. Well, for example, he talks about water from volcanoes and lava from volcanoes. How does that indicate a young Earth? Well, we've got about 600 active volcanoes in the world today. There's about 10,000 inactive. I think that talks about a very catastrophic circumstance at the time of the flood that was designed to destroy the world that then was. But in order to evaluate this, we've got to know what is the average volcanic situation. And probably the most studied and what's typically considered the average standard is Paracatan down in Mexico that we saw form and that we measured every way you can measure it, both from the kind of gas and what's coming out and the lava. Taking that as a standard, which is typical as you study volcanoes today. 70 of these, just measuring the water vapor, where the H and the O gets together to form H2O, the juvenile water. There's enough of that coming out, if you multiply it times 70, to account for all the oceans, but we've got 60 of them. 600 of them. 600 of them would account for all the water in the oceans 8 times. Nobody thinks the water in the oceans all came from volcanoes, but you can account for it 8 times in a billion years. It's supposed to be 4.5 billion, but let's just take 1 billion. You run the ocean over 8 times with what we see from Paracatan. Taking the lava 4, like Paracatan would account for the entire crust of the Earth in a billion years, multiply times 600 that we can see going on today, you've got the Earth's crust times 150. You see the problem for the great age assumptions. This says it's not that old. You look at the pressure in the oil reservoirs, and these are his reasons, the anti-creationist reasons, that he acknowledges indicate a young Earth. Down in Louisiana, we tapped into a reservoir with tremendous pressure that we just had a terrible time getting that thing turned off. Everybody here, I think, remembers that catastrophe. Tremendous pressures down there. How long will rock maintain the pressure? Well, if you study petroleum geology, you study the porosity of the rock, and from that it's fairly easy to know how much gas pressure it can maintain for how long. You're talking about tens of thousands of years at the most, 12 to 20,000 in order to maintain the kind of pressures that we see, and it's still there, and a lot of it's still there. Can't have billions of years. You drill into it and boom, and yeah, that can't be very old. We can measure very precisely the uranium accumulation in the ocean, detecting with the Geiger counters. That indicates tens of thousands of years. Likewise, radiocarbon in the atmosphere, which we had time to talk more about that. We see it building up. Libby, with his original work, for which he won the Nobel Prize in carbon-14, said it would reach equilibrium in 30,000 years, and it is not there yet. It's still building. It's about 20% short of it. So you can measure that. The radiocarbon assumptions involve assuming it's the same amount previously as we have today. In order to get the age, you compare the amount of radiocarbon in the atmosphere. It's not. It's building up. And that's really not a matter that is contested. Helium in the atmosphere, the same thing, was about 1/50,000 of what ought to be there according to the assumptions of the uranium-238. Every time you have one atom of uranium-238 decaying to lead, you have 8 atoms of helium produced. Okay, this has been going on 4.5 billion years. We're told 1 half-life, you ought to have 8 times as much helium as you have the uranium-238. 1/50,000th of that is there. Meteoric dust, again, these are reasons given by Stanfield that says, yeah, there is some evidence for the young Earth here. Meteoric dust in the strata, if this has been going on millions of years, and like 14.5 million tons of meteoric dust every year is estimated to be raining down on the Earth. Well, in this geologic column, which records what's happening through time, there ought to be a lot of it, but you don't find that in the column. But if it's all 1 year's flood deposit, you would expect a lot. Meteorites, likewise. If you accumulated this over 500 million years, you ought to see a lot of it. He says you don't see any. I think you do see some, but he says none, and it's certainly very little. Population dynamics is one of the most obvious and challenging issues that Stanfield says is a problem for the old Earth. Have you calculated that? We hear about the population explosion. It's bigger and worse than they would imagine. You've got to know the population growth rates. We talked a little bit about that Sunday, I believe. The CIA World Fact Book says the present growth rate in the U.S. is just over 1%. Yeah, some third world countries, it's 4%. But well, even less than 1%. Let's try it at about 0.5%. That is as low as you can get it, as conservative as you can get it without going extinct. Let's take 8 people for 4,500 years. See what we're doing from the time of the flood, 8 people, to today. 4,500 years. How many people would you have? About 7 billion. That's what we got. Well, let's look at 2 people for 200,000 years. That's just a drop in the bucket for the evolutionists. But man's been around at least that long. Same growth rate, 2 people, 200,000 years. 4.3 to 10 to the 398th. You know anything about scientific notation, you look at that and you say, that's wrong. That's silly. To give an illustration, there's 10 to the 65th electrons in the galaxy. And you've got 10 to the 398th. Let's move from the galaxy to the universe, it's 10 to the 80th. But 10 to the 398th, that is absurd. It won't work. But this one's right on. At 4,500 years since the time. It fits. And so when you study population dynamics, you see one fits perfectly and the other is nuts. There is really good evidence for the young Earth, which we haven't had time to really emphasize. We've just tried to look at the evidence for the old and show that there really is evidence for the young. What we're looking at as we evaluate the models is a great deal of good evidence for a young Earth, even acknowledged by the anti-creationist. On the other hand, the geologic phenomenon also is rapid, has not very good evidence. The radiometric dating systems have all kinds of assumptions, and it's not an objective system. It's pretty light evidence. Another way to say it is that on the one hand we have more and better, on the other hand we have fewer and not so good. Now, as a scientist, without the emotion, without the philosophical pressures, the intimidation, let's just look at the evidence and where does it come out? The best scientific conclusion is that the Earth is young. Not because of what Genesis says, or that is a good reason, but apart from that, looking strictly at the scientific evidence, this is the conclusion that is reached. Thousands, not billions, is the most scientific answer to the question on the age of the earth. Not because of religion, but because of the facts that we've been looking at this evening. All right, let's turn the lights back up and see if we have questions.